Y'all, trying to move my table here. Okay, we're going to look at some more of that polynomial worksheet that we were working on. Just flip my laptop real quick. And don't know what happened there. What's going on? Okay, so it should be right there. Okay, there it is. Had that. Okay, so where we're at right now is adding polynomials and subtracting polynomials. So whenever you add polynomials, they could either look linear. I'm trying to darken it again. And what I mean by linear is they're just in a line. Or they could actually be like stacked, like on top of each other. When we subtract polynomials, same thing. They will either be linear, as in just in a straight line, or they will be stacked on top of each other. So whenever you see them stacked, you can write them linearly. Linearly, it's a weird word. Or if they are written linearly, linearly, you could actually stack them. Okay, so it's completely up to you. It's your preference, whichever is easier. It's as long as you don't break any mathematical rules and you get the correct answer. In all honesty, like, doesn't really matter. Okay, so I'm going to look at the left-hand side where it says adding polynomials. These are not the same examples. Okay, I'm going to highlight them differently. Maybe, probably. Right here, I've got that polynomial. There are actually multiple polynomials, two of them, and those are being added. These are also two different polynomials, and they're being added. Over here, these would be the two that are subtracting, and that would be two polynomials that are also, the second one's being subtracted from the first one. Okay, so the only thing is, if it is written, as far as subtracting is concerned, if it is written in a line and you change it to a stack, you just really need to be careful with your sign, and vice versa. If it is written in a stack and you change it to a line, you need to also make sure, like there's technically parentheses and stuff. What you're doing is you're distributing that negative sign into that second polynomial. Doing so actually allows you to correctly and properly subtract polynomial from the first polynomial. If you aren't careful, you really just think that maybe it's, look at the stacked one. Oh, that's just a negative 5x cubed. It's really not just a negative 5x cubed. I feel as for continuity, I should have put parentheses on that bottom polynomial. What you would do is we will write them similar to our green highlighted subtracting with the parentheses on the bottom so that you can see that it is distributed. In the homework, I just think that sometimes there may be parentheses, sometimes there may not be. Usually if that 5 was a negative, it would have negative and then a parenthesis and then a negative. So then it's a little bit more clear that you are distributing that negative through. Sometimes you won't have the parenthesis, so you just need to know what you're doing is actually subtracting that whole second polynomial. So we'll add our own parentheses so that we can distribute. So what we're going to do, we're actually going to do an example of right here adding these polynomials to each other. These are the exact same examples. Example 1 and example 2. One is written stacked, one is written linearly. I did that for a reason. I actually wanted y'all to see that either way you do it, you will get the same answer. The only thing that I could not figure out how to do when I was typing this up was how to get a line on my laptop to draw underneath there. So there you go. Homework, it'll actually have a line. Okay, y'all. So let's go ahead and let's look at this. So what we have is purple, of course. Notice first that the terms that are written on top of each other are going to be like terms. So I've got that 5x to the 5th, and right underneath it, I have 2x to the 5th. Those are like terms, right? Because they have the same variable, same exponent. Those are written on top of each other. Then if you scoot over, I've got an x to the 4th term and another x to the 4th term. If you do see a polynomial being added to another polynomial, and it's like a binomial and a trinomial adding together. You just need to make sure that you line up the like terms, okay? And then what we're going to do is actually just perform this addition from left to right. So what we would get is 5x to the fifth plus 2x to the fifth. That is a positive 2x to the fifth. So because those are like terms, we would do math on the coefficients. I get 5 plus 2 is 7. Just kidding. There we go. 7. And then we went over it 2 videos ago, I guess, whenever you combine like terms, you do the combination on the numbers, and then you keep the variable and you keep the exponent, right? Right. So now scoot on over. We have a negative 6x to the fourth and a positive 3x to the fourth. Those signs on those coefficients are different. So what you do is you subtract, keep the sign of the larger, keep your variable, keep your exponent. That's the final answer, y'all. Okay. So if you don't understand what I mean whenever I say subtract, keep the sign of the larger, we do have videos on that. You could send me an email. You could comment. Just let me know that you need help with like the terminology that I'm using also. Okay. So let's scoot on down. Strip out there. I want to do this problem. We will get the same answer because they are the same. They're the same problem, right? But I just wanted you to kind of see it. So if you look at that first polynomial, y'all, if there's a way for me to ever kind of rewrite something and get rid of a symbol or simplify it in a way, like, of course, I'm going to always want to do that, right? Because I'm making it more simple. Well, that first polynomial, there's nothing like touching that parenthesis on the outside. If it said like negative parenthesis and then the polynomial, that would mean, of course, that we need to distribute that negative, right? But because there's nothing, what we could do is actually rewrite that first parenthesis, right, like what's inside of that first parenthesis without the parenthesis. And actually just go ahead and write 5x to the fifth and then a negative 6. Oh, so ugly. X to the fourth. Okay, so we have that. Now let's scoot on over. We've got a positive, and then inside of the parentheses, 2x to the fifth plus 3x to the fourth. Okay, so what's touching that parenthesis is a positive. Like, don't get me wrong, if you wanted to distribute there, it's a positive 1, right? So you distribute the positive 1, you multiply everything by positive 1, all the signs stay the same, like nothing changes, right? Since nothing changes, you can actually just rewrite that second set of parentheses without parentheses, okay? So we have a positive 2x to the fifth. Then we have a positive 3x to the fourth. Okay, now it looks a little bit easier, I think, honestly. And don't get me wrong, you don't even have to rewrite it without the parentheses. If you know for a fact that the polynomials, both of those binomials, do not change because there's not a negative being distributed anywhere, and then you can just go ahead and combine like terms. If you do want to see it written without all of those confusing parentheses, go ahead and rewrite it. And then now what we can do is just go ahead and solve it. So I need to look and see where are my like terms. In order for it to be a like term, what you need to do is make sure you have the same variable, same exponent. I never know what color I want. Okay, so do y'all agree with me? Ooh, what happened? There we go. 5x to the fifth and 2x to the fifth. Those are alike, right? Yeah, they both have x to the fifth. That means that I can do math on their numbers and I can keep and keep. That's a positive 5. That's a positive 2. Plus 5 plus 2 plus 7. Keep and keep. Okay, awesome. Now let's look. The next term that we have is a negative 6x to the fourth. And I've got another x to the fourth term. Kind of almost smudged out my fourth, but you see it, right? And that x to the fourth term is a positive 3x to the fourth. So let's look at my coefficients. I've got negative 6 plus 3. Signs are different, so you subtract, keep the sign of the larger, keep your variable, keep your exponent. If you have your calculator, you can enter that positive value in first, and then subtract from it 6, right? 3 minus 6, you'll get negative 3. Or you could also do the negative symbol 6 plus 3. I probably, just because that one could be tricky if you don't hit the right sign first, like it'll just tell you error. So it's easier to enter. It doesn't have to be the biggest number, y'all. It's just got to be the positive number minus the negative number, right? Or like I said, signs are different. Keep the sign a little larger. Okay, y'all. So similarly, we're going to do these subtraction problems. I don't think I should have to do 2 videos if I don't have to, okay? So what do I got? Oh, yeah, look at that one. That was actually kind of pretty. I'll definitely come back to do that one, okay, y'all? So let me see. The directions here just say subtract. So let's draw that line that I couldn't figure out how to do, like that. And then this is the one I want to show you. Okay, in that denominator, why did I say denominator? In that bottom polynomial, I have that negative sign, and then I just have the number 2. So this is actually top polynomial minus bottom polynomial. The way that looks now, it looks as if the 2 is the only thing that like is a part of that negative, right? It just looks like it's a negative 2, but that's not true. What we need to do is actually put this into parentheses, because if y'all remember, when you have negative sign and then you have parentheses, what you do is you distribute that negative sign through, right? So y'all, I'm actually going to come right here because we need to rewrite this problem. We have 5x to the 4th, a negative 6x cubed, a positive 2x squared, a positive 3x, a positive 1. Now for that bottom polynomial, because that is a negative sign and it is touching my parenthesis, that has to be distributed to each and every single individual term inside of that set of parentheses. Now, what that means is you're going to multiply everything by negative 1. And what that does is just the coefficient stays the same, but it just changes the sign. So negative times 2x to the 4th is negative 2x to the 4th, right? And then we have a negative times 2x cubed is going to be a negative 2x cubed. Then a negative times a negative x squared, those signs are the same, so I get a positive x squared. Negative 5x, those signs are different. I get a negative 5x. Then I get a negative 1, right, times a positive 5. 1 times 5 is 5. Signs are different, so it's negative. Now, I'm actually subtracting that second polynomial away from the first polynomial. If you only have that negative sign in your mind being a part of that 2, like whatever that leading coefficient, like that leading term is, then you're not taking into account all of the other signs needing to be changed, and your answer will be wrong. So just be careful there. So now let me erase this little black dot. Let me change to my favorite color. And now, starting from left to right, let's actually combine these terms. So 5x to the 4th minus 2x to the 4th. 5 minus 2 is 3. Keep and keep. Negative 6x cubed, and then like a minus 2x cubed, right? It's a negative 2x cubed. Negative 6, negative 2. Signs are the same. Add and keep and keep. Positive 2x cubed, positive x cubed. There's that invisible 1 right there, right, y'all? So what you do, signs are the same. Add and keep and keep. Okay, scooch on over. I got a positive 3x, negative 5x. Signs are different. Subtract, keep the sign up the larger, keep and keep. Even though it's just an x, I'm still going to say keep and keep, because what's the exponent on that x? Yeah, it's 1. It just happens to be that one that, I don't know, if we just don't like it, we're not friends, we don't write it, okay? It's just kind of invisible. Scooch to your constants. Constants are just numbers that don't have variables, right? What do I get? Negative 5 and a positive 1. Those signs are different. So what you do is you subtract and you keep the sign of the larger. And that's it. That's your answer. 3x to the 4th, negative 8x cubed, positive 3x squared, negative 2x, negative 4. I'm going to tell you right now, all of that point from negative 8 and on, will be completely wrong if you do not distribute that negative through to everything. Okay, and remember that shortcut. When you see negative parenthesis, whatever is inside of that parenthesis, what happens is all of the signs change, right? It's a 1. So that multiplications, the numbers are going to stay the same. The coefficients will stay the same, but all of the signs will change from whatever they are to the other sign. So I believe when it comes to subtraction, that linearly is actually going to be your best bet visually, just because, kind of rewriting the whole entire problem. Maybe just, I don't know. I feel like, oh man, I wrote the problem wrong, y'all. Right here, when I was typing, that should be a positive, okay? That was my bad. I do feel, though, that writing it this way, I like it a little bit better than doing it stacked. I actually like all of them better when they're not stacked, but it is completely up to you. On problem 2, just whenever you do write this problem, that second set of parentheses, that's supposed to be a positive 2x to the 4th, okay? I actually think it's pretty rare to have parenthesis negative something. So just make sure that you write that down as a positive, okay? Same exact problem. What we're going to do here is we're actually going to, the way this is, I'm so sorry. The way this is written, I don't know why it won't let me quieten my phone up. The way this is written, we're actually just going to, I'm trying to tell them, hold on, recording video. Okay. So I think writing this is better. I did not mean to have that additional negative sign. Okay, let's go ahead and do this problem. If you notice that first polynomial, there's not, I don't know why every now and then I get an extra little decimal. There's not a negative sign there. I mean, that's like what I'm going to stress the most. Negative parenthesis means that, you have to distribute that negative in. I noticed with that first parenthesis that there's actually not a negative there, which means if I want to just rewrite it to get rid of the parentheses, I can. Okay. Honestly, if you look at both problems, I'm rewriting them. It's just a matter of which way do you like it to be written. 5x to the 4th, negative 6x cubed, positive 2x squared, positive 3x, positive 1. And then let's go ahead and distribute. That's a negative times a positive 2x to the 4th. Sorry for my typo. So kind of cover it up. What you figure right now? What I got? I got a negative times a 2x to the 4th gives me negative 2x to the 4th. And then that would be a negative 2x cubed. That would be a positive. I'm sorry, x squared. No, it was cubed. That was right. And then right here, I got a positive x cubed squared. That phone call messed me up, y'all. Messed up my focus. And then now I have a negative 5x, and then I have a negative 5. Okay, so very messy, very sloppy. Let's go ahead and look through here, find things that are alike. 5x to the 4th with a negative 2x to the 5th. 5 minus 2 is 3. Keep and keep. Then we have a negative 6x cubed, a negative 2x cubed. Signs are the same. Add and keep their sign. Keep and keep. A positive 2x squared, a positive x squared. Signs are the same. Add and keep and keep. Da, 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 da. And then we have a positive 3x and a negative 5x. Signs are different. So you subtract, keep the sign of the larger, keep and keep. And then we have a positive 1, negative 5. Signs are different. So you subtract, keep the sign of the larger. Okay, y'all. So do you notice how they are the same? you have to rewrite both of them. I'm going to go up just a little bit. It is a matter of preference. Okay. If, say, there are some missing terms, I don't know if the homework will kind of trick you like that. One polynomial might have to the fourth, to the third, and then a constant. And then the other polynomial has to the fourth, to the third, squared. They have all of the exponents. If you do have it stacked like this, you would need to add a couple of zeros just so that everything lines up. And that way would probably be a little bit easier to solve and see than this second part right here. As long as you get the same answer, it's really okay. With these, it can get very complicated, very confusing. So just make sure you just kind of keep checking yourself. Okay. Sorry for the phone call. I do need to call them back. I'm going to come back and do this one right here. And then I'm going to do, I guess it's kind of typically like a geometry application problem. It's going to have us finding the perimeter of this rectangle. And instead of it just being like a numerical value, it's actually given to us in polynomials. So I will be back in a little bit. If y'all have questions, please make sure you ask, especially since I had typos and phone calls in life, and it happens. Okay, thanks y'all. Bye. Maybe. Bye.